Okay, so we're going to step away from static electricity and now move into looking at current electricity or electric circuits. So this first part here today is going to be kind of an introduction to circuits, kind of what are the different components that have to be part of a circuit for it to work, and then we'll talk later on about how electrons are actually flowing. Okay, so a simple electric circuit. So a circuit is essentially a pathway for electrons to flow. Okay, so it's important to understand that circuits can only be done using current electricity. So remember, static electricity, you can have movement of electrons, but it's not a continuous flow. So you might have electrons moving from one object to another object, but it's not like they're flowing around in a circle from one object to another continuously. So what we're looking at here is now looking at electricity that's basically flowing through wires that are traveling through different materials. So for example, maybe a light bulb or a buzzer or a motor. Okay, so we're going to look at different things that essentially make up a circuit. So as I mentioned already, we've already talked about this, but current electricity is where you have a flow of electrons. And the electrons have to be flowing in a pathway. So that pathway that they are flowing on is what we call a circuit. Okay, so there are four main components for circuits. Okay, so I should say requirements. Now you don't have to, some of these you'll see you may not need, but some you can't really have a circuit without. So first of all, you need to have an energy source. So this is actually where the electrons are being produced. So of course we need to have an electric source, such as, an example here being a battery, because you have to have the electrons coming from somewhere. Like the electrons that are flowing, where are they coming from? Right? So they're coming from, most of our circuits we're going to be looking at are going to be involving batteries. Okay? The next component is something called a load. Okay, so a load can refer to many different things, but the purpose of the load is always the same. So a load will take electrical energy and convert it into another form of energy. So of course, the electrical energy we're referring to are the electrons from the battery, and we want to convert it into a different format. So for example, a light bulb. Light bulbs are also referred to as lamps. So if you ever read, you're reading something in your textbook or online somewhere that says there's 3 lamps. You're like, oh, what's a lamp, right? Not like the lamp that might be in your living room. Okay, so a lamp in electrical circuits is essentially the exact same thing as saying light bulbs. So 3 lamps means there's 3 light bulbs there. But light bulbs are not the only type of load. For example, a motor or a fan, or a heater, a speaker, right? Something that's taking electrical energy and converting it into a different form. So of course, a light bulb takes electrical energy and converts it into light energy. If you've ever gone near a light bulb, you probably notice it also releases heat energy, right? Infrared or thermal energy. Think of a speaker, right? So it takes electrical energy, converts it into sound energy. Looking at, let's say, for example, a fan that's turning, right? So that's taking electrical energy and converting it into kinetic energy or movement. So the fan's able to kind of turn around. So anything that takes electrical energy and converts it into usable energy, right? So the whole purpose is we want to use our electricity to do stuff, right? We want to turn on our laptop. We want to turn on a light. We want our fridge to be cold, right? All these things are loads. That's kind of the general category they're under. So another part of a circuit that's required is a conductor. So a conductor essentially is what links the different parts of the circuit together. Pardon me. So a conductor is essentially wires, right? So if you have a battery and you have a light bulb, you have to way of connecting those two things so that way the electrons can move from the battery into the light bulb. We do that using a wire, right? And it has to be a conductor because we want the electrons to flow. If you remember when we talked about conductors and insulators, insulators do not allow for electrons to flow. Conductors do. So all wires are essentially made out of metal, right? So we have metal on the inside of the wire. So you're probably wondering, well, wires you don't see the metal. It's because there's a protective plastic usually that's coated on top of the metal, because remember, metals are conductors. So if you were to touch a metal that has electricity flowing through it, you have the you could be electrocuted essentially, right? So if you're touching a wire that's live that has electrons flowing through it, the electrons can flow through you and cause you harm. So wires, even though there's metal inside, right, we usually have an insulator that's on the outside that is protecting just for safety purposes. Okay, and then lastly, we have a control. So a control is something that allows us exactly kind of what it sounds like. It lets us control the flow of electrons. So for example, a switch, right? So if you don't have a control, that means that the electrons will always be flowing. So it's like, imagine if you have a light bulb hooked up. If there was no control, the light bulb would be on all of the time. But we want to have the option of turning the light on or turning the light off, right? So we have to have a way of controlling the electrons. Let the electrons move or have the electrons not move. Right? So that's called a switch. Think of like your light switch in your bedroom, right? You turn on the lights or you turn off the light. You're using a switch to do that. It's a control mechanism. Okay, so here's just like a general kind of picture showing you a very simple circuit. So here we have the battery. And what I want you to notice is batteries always have, and I'm sure if you've ever seen a battery or if you put one maybe in like a remote control or maybe a toy or like a video game controller. Anyways, if you've ever looked at a battery, there's always a negative symbol and a positive symbol. And if you've ever put it in the wrong way into the controller, you'll notice that it doesn't work. And the reason why is because it is important the way that we orient the battery. The electrons always flow out of the negative terminal. Okay, so these are called terminals, a positive terminal and a negative terminal. So the negative terminal is actually where the electrons come out of the source. So it's important that you have it in the right way, because if this is the pathway we want the electrons to flow on, we have to make sure that the electrons are basically pointed in the right direction so they're able to flow properly. Okay, so here's our battery. Here's our control. So this is the diagram of a switch in a circuit. So it might look a little bit different than your switch that might be on your wall in your room, right? So we'll talk about this a little bit later, but when we're looking at a switch, there's going to be kind of pictures we're going to use to represent things. So this switch here, so the lines, all the lines we draw are representing wires, right? So here we have a wire and then another wire, and you'll notice there's like a gap in the middle. So if you go back, see how there's like a gap here? So this gap means that the circuit right now is turned off. The electrons are not flowing. The electrons will only flow in the circuit if there are no gaps. So right now, this switch, this control, is open, which means the circuit is off. So this light bulb is turned off. So this right here is showing an open switch. We'll see this picture again. So a closed switch will look pretty much the same. You have those two ends, but it will be completely locked in with each other. So you have a continuous line. So this is a closed switch. So a closed switch means if we had a light bulb in this circuit, the light bulb would now be on. So right here, imagine if this piece swung this way and made a straight line. Imagine that bar was closed. What that would now mean is the electrons are able to flow, so they would continuously flow, and then they would turn on this light bulb. Okay, so it's important when you're looking at diagrams to recognize if you have a switch that's basically on or off, right? Depending on if there's a gap or not. Okay, so there's actual, so the conductors, like I mentioned, all of the lines are representing wires, right? So remember that the wires are basically connecting one part of the circuit to another part. And then our load in this case is a light bulb. All right. So I've already mentioned a lot of the points that are already on this, so we'll go through this quickly here. So energy sources. So energy sources is essentially what gives us our electrons. So we have batteries, and of course we know we can get electricity from an outlet. Now, the type of electricity we get from the two of these are going to be different. We'll talk about this later on, but just briefly, batteries have what's called a direct current. So what that means is the electrons are only able to flow in one direction. Okay, so it's called direct current or DC electricity. Electrical outlets have what's called alternating current, which means that electrons can flow in and out of the wall outlet. And actually, if you've ever seen, probably not going to be that great of a drawing. If you've ever seen a plug, the two prongs, so usually you have a, oh, it looks like somebody's like a scary face, but the two prongs that are up on top are actually the direction of electrons going in and going out of the wall connector. So alternating current has a flow, a pathway for going in and a pathway for going out. But all of the circuits that we're going to be drawing and that we're going to be dealing with are going to be with batteries. So it's going to be direct current only. So meaning there's only one flow of direction. So electrical loads, we've already talked about this. So a load is anything that takes electrical energy and converts it. So we've already mentioned a bunch of these. So a light bulb or a lamp creates light energy, right? Motor creates mechanical energy. A heater, thermal energy. Speaker, sound energy, etc., etc. So anything that you essentially use electricity to run is considered to be a load. Okay, so a control device. So a switch, so here you can see the open and close a little bit better. So here's the open switch, so meaning this is not connected. So you have to imagine like a wire would be here and here. So there's a gap. This wire is not connected to this wire. But here's our wires. Once you have the closed switch, you then have a full connection so electrons are able to flow through freely. Now there's another type of control that I haven't mentioned yet, and it's called a fuse. A fuse is not this, it's not the same as the switch that we can turn it on and off. The fuse is similar to a switch because this is it's basically like a safety switch. So here you have a small wire inside the, so you have to imagine like here's a wire connecting the rest of the circuit. This is creating a closed circuit, so it's able to run. But what happens with a fuse is if you ever have too much current, or I should say, if there's ever too much electricity flowing through here, what happens is this little piece of metal basically will melt and cause a break on the inside. So the metal will kind of split apart inside this tube. So what happens then is it basically turns off the circuit. So the reason why that happens is because if there's too much electrical current in a circuit, you can sometimes create an electrical fire, okay, which obviously is not good. So this is essentially a safety mechanism. Maybe you've heard the term of somebody blew a fuse, or maybe like inside of a bathroom, the lights all shut off because the fuse was blown. What that means is there's too many things being used at the same time. So maybe the hair dryer's on and a straightening iron, and somebody else is blowing their, using a hair dryer. I'm trying to think what else you'd have in the bathroom. But you have too many things plugged in that are being used at the same time. So as a safety mechanism, basically the circuit gets shut down because of the fact that it could cause a fire.